Okay, so hello and welcome. See if this is working. Let's see, check my audio. Hello, hello, hello. Hello, hello, hello. Excuse me. Hello, hello. Is it working? Yes. Hello, hello. Very good. All right, here we are. On to the next thing here. Replace the substring for balanced string, number 1234. Let's continue the journey here. LeetCode journey. Yes, let's do that. Let's do that. Gee, these questions are insane. These questions are crazy. I want to finish the last 40 questions, 39 questions that I have here to get to 1,000. And then I have a lot of things in like real life I need to attend to, and like this is taking too much time. Bluntly, this is just like probably not the best use of my time at the moment, given the situation that I find myself in. Yeah, but for now, just want to get this done and then move on. And then do something. There's a lot of other things I need to do, like a ton of other things. Replace the substring for balanced string. You are given a string S of length n containing only 4 kinds of characters, Q, W, E, and R. A string is said to be balanced if each of its characters appear n over 4 times, where n is the length of the string. Return the minimum length of the substring that can be replaced with any other string of the same length to make S balanced. If S is already balanced, return 0. So example 1, QWER, 0, S is already balanced. QQWE, 1, we need to replace a Q to R so that RQWE is balanced. Are these, is this just like it's a pretty low acceptance rate and kind of a low submission rate too. What? Minimum length of the substring that can be replaced with any other string of the same length to make S balanced. If S is already balanced, return 0. Each of its characters appears n over 4 times and is the length of the string. Can the string be, oh, it is a multiple 4, okay, all right. What if it can't be made balanced? This is an interesting question. It's already balanced, return 0. Okay. So the frequency of each of these characters is what I want. And I want to somehow replace a substring. It's a relatively long string, so I can't, it's got to be like linear rhythmic or better, the solution. Definitely going to need to get the frequency, which I could do that in linear time of each of these characters. That's fine. Actually, constant memory, technically, by the way. I've got to replace some substring in order to balance the frequencies. So I could maybe use a binary search. No. There's a quadratic number of different substrings that can be considered, and I could always simply replace the entire string with something that's balanced, right? So there is an upper bound on this. It's always possible, and there's an upper bound as well. You know, it could be I think I could use a binary search. Because if it's possible to replace, I think I could do this with the binary search. If it's possible to replace with this particular string of a certain length, then all of the larger, like I don't have to look at the larger amounts. Yeah, I only need to look at smaller amounts. If it's not possible, then I should look at a larger amount. No, if there's a smaller substring size that it's not possible, then I should go up, look at a larger size. Yeah, you could use binary search. Yeah, this is not too bad. I should be able to do this in n-log n time. Okay, so frequency of 4. I don't know if I could do it this way. I tend to forget. Also, tend to forget if I could do it that way. Also, not that way. The standard array. Some people use standard. I maybe I should start using that. It's a good habit. I can do it that way. I like this. This is good. I think standard array is good, and I should use it more. Okay, I can do it that way. All right, cool. Okay. So, can I do this? I think I can do this too. Oops, not that one. I think I also can do this. Yeah, and this is just 0. Does that work? Don't mind me, just gonna check quickly. I think I can do it like that. Let's do 3 and 2. So what if I do 3, every element, empty initialize list, empty initialize every element of the array? Okay, I think I want 3. What about 2? 1. 1 initializes for character and wide character arrays. 2 constant expressions initialized for array elements optionally using array designation. Oh, this is C. I want C++. Oops. Oops. Language lawyer. Aggregate initialization. I think this is what I want. Yeah, this is what I want. Okay. 1 ordinary initialize a list. Aggregate error. Okay. Union initializing elements explicitly initialized as they initialize the list. Copy initialized. I'm looking for race elision. I'll come back to that. Another time. Looking for something specific. The syntax for array initialization in C++, it's different from C. I really should get the ICE of the standard. Aggregate type, it can be initialized with aggregate initialization. Okay. C style array doesn't decay automatically as aggregate type. I think I want syntax declarator assignment. Modified as a whole, L values. Even though they're L values, the cannot appear on the left-hand side of the assignment operator. Error is an array. Yeah. Rate of pointer decay, multi-dimensional arrays, arrays of unknown bound, array value, R values. Pure values can be formed. Okay, interesting. X values. I'm looking for shoot. I don't even know how to describe what I'm looking for. I just want to know if this is legal, like this is a reasonable way to. In other words, I just want to know if this initializes everything in the array if I do it this way. I think I can remove this element, but I saw somewhere something like that you can use a single element that actually ends up initializing everything. I just don't remember where the where, if I want to verify that, where that is in the documentation. Assignment. Structs of the array members. Okay, interesting. And can be assigned. Whoa. Oh, that's interesting. S1, S2. Okay, interesting. Gets confusing, huh? Looking for, where is array declaration? It's not declaration, it's assignment. It's really array initialization. Maybe I should just do array initialization. Oh boy. Okay. So maybe we'll just assume it's the same, similar in C. Same thing. Okay. Brace and close lists. All right. Okay, that's exactly what I'm looking for. Initialization from brace and close lists. So here, this is 1, 2, 3. Here, 5 has 1, 2, 3, 0, 0. Oh. Wait. Oh no. Wait a minute. What? What? Element at index 0, and each subsequent initializer without a designator initializes the array element at 1 index greater than the 1 initialized by the previous initializer. No. So it doesn't do what I think it does. Okay. Anyway, that's confusing. All right, I didn't understand that completely. So you can do it this way, but can you do it this way? I think it still. I'm assuming it also works with standard array. This is confusing. You know what I'm going to do? I'm just going to skip all that and just keep it simple and just use a fill. Simple. Anyway, so here I am taking too much time on this question. This should be A. Oh no. Oh no, actually. Oh yeah, I guess I'll use a switch statement. Never mind. QWER. Yeah. Okay, that's fine. Q W E and R. And the reason why I would use a switch statement is because I could use a frequency map with 26 values, but I don't really need that. The code would be a little bit simpler. But the ASCII values, but yeah, these ASCII values actually aren't A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. Yeah, they're not in sequence. So we'll just assign them values. And then, yeah, what I was saying was I could use a binary search, right? So A is 0. B is going to be size const int n is s.size. And we just say it could be n. We'll say while, and I think I have a best, which is really the smallest value, equals n. A is less than or equal to b. I'm going to return best. I'm going to run a routine. The midpoint is a plus b minus a, pitch shifted by 1. And I'm going to say if there's going to be a check. If that check succeeds, then that means we can say best is equal to mid, right? We're going to go go smaller. If it succeeds, then I'm going to update b to mid minus 1, go to the left. If it does not succeed, then I need to go larger, a is mid plus 1, and then return the best one that I see. Yeah, this only ever gets smaller. So if, now what's the check on the midpoint? The check is going to be a loop. And how does this work? Target frequency is going to be n over 4 for each of these. To check, I'm just going to check each string one at a time, add and subtract. So I can have like a current frequency. So current frequency, size 4, let's use standard array. Current frequency, which is empty. And then we're going to initialize for int I is 0, I is less than mid, increment I, current frequency. Maybe I should use a switch statement. This is maybe a little more code than I would prefer typically. CH is S of I, right? Then same thing from here, from mid to end. So next CH, previous CH is I minus mid, next CH, S of I, right? And previous CH, it's going to be decrement, each of these. Maybe I should just use a map, actually. Tempted to do that. And the other one is increment. It's a little awkward, actually. This is a little awkward. I don't know about this one. And it's supposed to be current frequency, not previous. Yeah, it's maybe. Maybe I should be using a slightly different approach. I don't know. This definitely takes a while to write it. I could have just had like empty, like the arrays just be a little bit longer and not use switch statements, because it's just a lot of extra typing to use the switch statements. Or you could use a map. Like there are a few different ways I could have done this. I think it's okay though. All right. So yeah, so this will give me the state of the current frequency. And basically, if for all, basically pretty much all const bool check or works. Let's do bool works is false, works and not works. It's gonna be standard all. There's some kind of for all routine here. All of, yeah. All of. And it's going to be frequency. Actually, It's awkward. Yeah, I don't know. It's maybe a better way to do that, but I'm not gonna do it like that for now. I is less than 4, increment I, works is, or let's just say current equals true. Current and equals current frequency of I plus, so I'm going to how do I do this check? For that particular substring, I'm going to count the frequency and I'm going to modify those characters, switch them in order to make the full string have the right frequency. I think I need to have the current, so frequency of I minus current frequency of I has to be less than the target, which is always going to be n divided by 4. It's always got to be less than the target, right? Or equal. If it's not less than or equal to the target, then this is not satisfied, right? Yeah, in other words, you subtract these current characters, and if all of them are less than or equal to the target, that means the characters that you have that you're now going to switch to other characters can just be rearranged to satisfy what's needed. Yes. It's the only time it's not possible is when at least one of these characters are above the target, and in which case no amount of switching characters around can reduce that, right? Yes, that's the idea. I think that's correct. All right, so works is then going to be equal to or equals current. Really, initially, it's just going to be current. And then you perform the same check at each point. So set current to true, and then so after performing these modifications, set current to true, and then also perform this works equals current. It doesn't have to be or equals because, I mean, it could be or equals, but it doesn't have to be or equals because this is immediately going to exit. So if this is false, it enters here and then checks, and then just keep setting it to false over and over. So if works, then we perform this binary search. Okay. Hopefully that makes sense. Excuse me. Yeah, so it'll do a linear amount of work, a logarithmic number of times, which should give me n log n time overall. Pretty awkward, actually, programming this, but oh, okay, doesn't work like that. All right, I guess I have to do it that way. Yeah, I suppose. Okay. Could be missing something here. I don't use the standard arrays very much. It's ironic too because the standard array is not what I would refer to as the standard array. In other words, like the basic array is not the same thing as the standard array. Maybe we'll try some other test cases. So can this be empty? No, it's gotta be at least 4. Let's do QQQQ. Let's do www. Let's do WERQ. Let's do QREWW. Let's do EERR. Okay. Just add a bunch of things. Oh, I got disconnected at some point. 25 minutes in here. I think this is correct. I kind of want to go for it. I'm afraid to go for it, but I kind of want to go for it. The reason I'm afraid to go for it is because there's a pretty low acceptance rate. I suspect there's a good chance it's wrong. I'm gonna go for it. I didn't do enough testing, but I'm gonna try it anyway. Oh, got it. Sweet. Nice. Yeah, it's linear time. That's pretty good. Or not linear. Nlog n. It's nlog n time. Yeah, linear rhythmic. It's linear rhythmic. That's okay. I mean, not the fastest solution, evidently. Let's see. Yeah, not the fastest solution. I'm kind of surprised. Programmed it to be pretty fast, actually. A little bit surprised it's not that fast. Dang. Dang. How much time did this take me? This took me, yeah, like half an hour. Yeah. All right, let me try a slightly different approach, which is going to be like the following. Let's try this one without the switch statements. Yeah. Slightly different approach. So this is just, I could hard code this part. And this is a little bit better. So these are going to be Q is A, B, 0, B, C, D, E is 4. E, F, G, H, I, J, K, L, M, N, O, P, Q. I think it's like 21. R is 22. E, W, R, and Q, and R. A, or B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W. This is not 22, this is like 16 or 17. This one I think is Z is 20, C is 25, Y is 24, W, X, Y, Z, X is 23, W is 22. It's something like this. I have to double check that though. A, B, C, D, no, B, C, D, E, F, G, H, I, J, K, that's 10. A, K, L, M, N, O, P, Q, that's 16. R, 17. Yeah, there we go. Okay, I could do it this way instead of having all these switch statements. And then both of these could be replaced with these two. Current frequency Previous CH and next CH. This is subtract and add. Okay. A little more terse, and maybe it's a little faster. I don't know. That's what I'm hoping. Hoping this is a faster program. Try this, see how this goes. Maybe, maybe not. I don't know. There we go. That's a lot faster. Yeah, I don't know. I guess the switch statements were just slow, but that's quite a bit faster. These are a little bit less, more memory though, but not much. There we go. Okay, this is what I was looking for. Yeah, it's a little faster to program too. It's hard coded. I realize these numbers. I could also have just made these constants and written them in, you know, just like you could write out a string, like something like A, B, C, D, E, F, G, dot, 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 right, so on. And then you can just say, you know, const int Q index, Qi index is going to be standard find in this array, and then, you know, subtract like the beginning portion of it, something like that. I could have actually written, like, programmatically found those constants at runtime, maybe made them const expressions or something, and then written them here. That may have been better. Program them that way. That would have been good. Instead of doing it by hand and then hard coding it, which takes a little bit longer, quite frankly. Yeah, you could do it at compile time. Could do that at compile time. So this is faster. This is not optimal. I mean, no. It's pretty it's a pretty fast solution. It's not a. I think the fastest solution is probably a 2-pointer solution. Actually, a sliding window. I suspect you could use the sliding window for this. In other words, you can start at a left endpoint and then move the right endpoint as you go, and keep checking to see if you're able to replace. I don't know. Maybe it's the other way around. Actually, it could be you shrink down. Maybe it's what something with a sliding window in the other way. So you start from something that works and keep kind of moving the left and right sides down as you go. Maybe that's possible. I don't know. All right, I'm going to stop here. It might be possible to do that. I don't know. I'd have to think about it a little bit more. I'm actually not sure about that, but I know this works, so this is fine. This is, sorry, I said it was optimal before. No, it's not necessarily optimal. Maybe you could do this in linear time. I would suspect that you can, because this is not the fastest solution. It's faster than most solutions, but not the fastest. Which makes me think that there might be a sliding window solution out there. It is relatively fast, though, to be fair. It is pretty fast. Yeah, pretty good. Pretty good. All right, I'll stop here. Let me just check to see. I'm sure there's a linear time solution. Sliding window, yeah. Okay, there you go. Yeah, sliding window. You could do both. You could do sliding window. You could also do excuse me. You could do sliding window, but you could also do a binary search. Binary search is a little bit easier to think about, I think. All right. Thanks for watching. If you liked the video, give it a like and subscribe for more. I'm going to stop here and restart on a new question. Let's do it that way.